Hello everyone, my name is Ramya and today I'll be talking about biases in generative art. At the outset, this topic may seem quite distant from ML fairness, but hopefully by the end of this talk, you'll be able to connect the dots. Here's a quick outline of this talk. First, I'll be introducing about what generative art is. Then I'll motivate the problem of biases in generative art with some illustrations. Then I'll discuss some background materials from art history and causal inference that will aid us in understanding the rest of this talk. The talk largely will cover some case studies to illustrate different types of biases. And finally, I'll conclude with some pointers which would hopefully help designers and developers of generative art platforms to be more mindful about the biases that can be there. So with that, what is generative art? Generative art refers to art that in part or in whole has been created by an autonomous system. An autonomous system here could mean any non-human system, so it could include even traditional processes such as styling. But more commonly, generative art is associated with computer-generated art. In fact, it is having quite a bit of history starting from 1960s. And more recently, AI-based generative art is gaining a lot of popularity. So here on this slide, you can see two illustrations of AI-generated art. On the left is a portrait by a GAN model or generative adversarial network model. And this portrait sold for nearly 400,000 US dollars, about 45 times its expected value or estimated value. And on the right are three other GAN-generated images displayed in the prestigious HD Contemporary Gallery. So these illustrations show the rising popularity of AI-generated art. Indeed, this is a very big market with a lot of auction houses and also user-friendly tools. And so this art industry, generative art industry, is expected to grow nearly exponentially in the next decade or so. But amidst this growing popularity, there are also some rising concerns about the biases that can be embedded in generative art. So as an illustration, consider this photograph of actress Tessa Thompson on the left, and on the right is a portrait version of this actress as rendered by an app called AI Portraits. So in this platform called AI Portraits, users can upload their selfies and the app would convert it into a portrait in the style of famous artists. As you can see, the skin color of the actress is lightened in the app's portrait rendition, and this was a common problem across all dark-skinned people. And later it was found that this was because the app was trained using about 45,000 white Renaissance portraits. So clearly, biases in training data and algorithm could result in discrimination based on sensitive attributes such as race and gender. This was an example to show how algorithms could stereotype artists and not reflect their true cognitive abilities. So on the left, you see a photograph of red flowers in the field, and in the center is a Van Gogh version of this photograph as rendered by this model called CycleGAN. And clearly the affect conveyed in the original photo is reversed. So a bright flowery spring season is converted into a winter dry season. And this is much in contrary to Van Gogh's style. As you can see on the very right is a real artwork by Van Gogh titled Green Years of Wheat, which is an 1888 artwork. And Van Gogh heavily emphasized on colors in his artworks, as also substantiated by his quotation as shown in this slide. So more generally, biases in generative art can have long-standing adverse socio-cultural impacts. Historical events and people may be depicted in a manner contrary to the original times, and we will see an example of this in one of the case studies. And because people have a tendency to believe results from computer as opposed to evidence from historical sources, this contributes to bias in understanding history and can come in the way of cultural preservation. So in this talk, we will be providing an investigation of different types of biases in the generative art pipeline, right from some types of biases that can arise due to improper problem formulation to those that can be related to algorithmic design. And we will also discuss some of the socio-cultural impacts of such biases. And more importantly, I'll be providing with a method to visualize these biases by leveraging directed acyclic graphs. And we will look at different illustrations. And finally, I will conclude with some pointers. Just making sure my slides are synchronizing with my talk, right?
Yes, these are.
Okay, sounds good. Okay, so with that, some background in art history. So I'll be using some terms throughout this talk, so I'm just going to define them. Art movement is a tendency or style in art, which is governed by some common themes such as culture, geography, and so on. As an example, you can see in this slide on the very left is a landscape belonging to 1392 to 1573 time period. It's a Japanese art movement called Muromachi period. In the center, you can see an Aztec art. On the very right is a modern art belonging to an art movement called Impressionism. So these have been divided into different art movements based on the time periods and geographies as they are defined. Genre is something that most of us relate to. It is just to do with the theme or the depicted objects in the artwork. It could be landscapes, portraits, and so on. Art material is the substance used to create the artwork. This concept of artist style is rather abstract and complex, right? Because it's governed by a lot of factors, some of which may be observable, but most of them can be even not observable, like the artist's beliefs, their cognitive skills, who would have influenced them, and so on. So it's quite hard to computationally model artist styles. And it is here the directed acyclic graphs can be quite handy to visualize the process of art creation. Specifically, the directed acyclic graphs or DAGs are visual graphs which can encode causal assumptions between variables of interest. These variables of interest are represented by nodes. For example, in this DAG shown in this slide, if X represents the artist and Z represents the artwork, the edge from X to Z captures the causal influence of the artist on the artwork. But in this process, there could be several other factors that can influence both the artist and the artworks. For example, the genre G, the art movement A, the material, art material M, and furthermore, their art movement could influence art material also, like in Renaissance, people heavily emphasized on marble and so on. And so this is just one set of assumptions that has been encoded in this DAG. And depending on the opinions of different art historians and other domain experts, there could be multiple DAGs. And the advantage of such a visual graph is that it will help non-domain experts, like people who are not necessarily familiar with AI, to encode their assumptions. And it is possible to test for biases under varying assumptions also. So with that background, let's move on to the case studies. These case studies were largely selected by surveying academic papers and online platforms, and it covers a variety of art movements, artists, and genres. So we will look at these through the illustrations themselves. So with that, we'll start with problem formulation bias. So the very first step in any AI pipeline is to define a problem. And based on how the problem is defined, bias can arise. So as an example here, the cycle GAN model that we discussed earlier is also used to mimic certain art movements. In this case, they say they mimic a movement called ukiyo-e, which is a Japanese art movement. On the very right, you can see 4 artworks generated by cycle GAN, shown one below the other. And the authors claim that because these are yellowish in color, much like the woodblock prints of the ukiyo-e period, the model has learned to mimic ukiyo-e. But ukiyo-e was characterized by many complex features such as asymmetry of design, exaggerated foreshortening, and also imaginary cropping of figures, as you can see on this very left bottom image, which shows a crane and elephant which are merged together. So clearly, and also these are across different shapes, not just yellowish in color. So by merely defining the art movement based on color features, there is a bias in understanding the nuances and the subtleties associated with the art movement. So this is just one example. There can be several others. So I'm just discussing one instance for every step in the AI pipeline. So we saw that defining the problem is the first step. Once the problem has been defined, the next step is to curate a data set to solve the problem, right? And based on how the data set has been selected, there can be bias. And we also saw an illustration earlier with AI portraits, which was trained using mostly white Renaissance portraits, right? And this can also be visualized using a DAG. Here, going back to our example where X was the artist and Z the artwork, here the artwork selected in the data set were selected by a certain process, like in that case, it was mostly white Renaissance portraits. So that is indicated by a special node here, denoted as S by the concentric circle. And there are also a set of conditions called as selection backdoor criteria, which tells when selection bias can happen. And specifically, if there is a path or an edge from the output variable of interest and the selection node, then there is a selection bias. I won't be going into the mathematical details of this due to the time restrictions, but basically DAGs offer an easy way to visualize if there is any bias, selection bias, even without checking for the model or its architecture. So this was an example of bias associated with dataset curation. There can be several biases associated with the algorithmic design itself, and one such is confounding bias. Basically, confounding biases arise due to common causes between variables of interest, in this case, the artist and the artworks. And we saw earlier that genre, art movements, art material could be some factors, not all of them. There could be several others, even such as the emotions of the artist, which are unobservable, as indicated here in the right DAG by the dotted lines. Dotted lines basically denote unobservable features in a DAG. So based on the DAG, it is possible to see if causal effects are even estimable or not. So in the right DAG here, because there is this emotion, artist emotion, which influences both the artist and the artworks, the causal effect of X on Z, or it is not possible to model the artist style. So again, using tools from causal inference, it is possible to visualize if there is any confounding bias and how it is possible to overcome or adjust for this confounding bias. Again, I won't be going into the mathematical details, but this is just an illustration. Perhaps one of the most common types of biases associated with generative art, it has to do with style transfer. And as the name suggests, it's basically converting the style of one image according to the contents of the other image. And we can understand this best with an illustration. So here in the left, you can see three images. The center one is a real artwork belonging to an art movement called Cubism. It's titled Propellers. And in Cubism, it was common for artists to depict the advances, technological advances of those times. So Industrial Revolution was just setting in, and it was common for artists to showcase that through artworks. And on the right, very right, you can see a futurism artwork called Armored Train in Action by artist Dino Severini. And in futurism, artists heavily emphasized on kinetic patterns and movements. It was common for these artists to express their opinions about wars and other political movements through artworks. And so this is a train that is moving through the countryside with all the gusts of wind coming out, and it was an armored train, so it's depicting war-like situation. And on the very left is the conversion of the center image according to the style of the right image. And you can see that movement, which is a key factor of futurism, is missing in this. So for the propeller, the movements associated with the propeller had to be depicted, but this style transfer is failing to capture this. And we can again visualize this with this DAG as captured on the very right, shown by these squares denoted as R. And these variables show the differences in the environments. In this case, the environments are the two art movements, and under what circumstances the causal effects from one environment can be transferred to the other or not. So this is another example of style transfer bias, and this shows how certain cultural subtleties associated with different regions can be overlooked in style transfer. So images 1 and 3 depict real artworks of young men belonging to the Renaissance time, and during those times it was common for young men to have long hair from the ears extending up to the shoulders even. And this platform called Abacus, which claims to do gender translation, fails to notice that these are images of men, and instead the translation shows masculine faces with beards. So it mistook these portraits to be those of women. And this is another illustration of racial bias associated with style transfer. On the very left is a folk art by Clementine Hunter titled Black Matria, which has been transferred to Expressionism version in 2. And you can see that the face has been tinted with shades of red, but that's not the case for this white marble belonging to the Renaissance time. And there are more such things. Here, this is another illustration of style transfer bias, where the nuances of the art movement has not been captured, but merely the color features have been reflected. So the very right image shows expressionism art movement, wherein artists emphasized on exaggerating the features to show the emotions associated with the person. So here you can see the pointed cheek and the elongated nose, which is absent in the translated version on the very left. So these were some illustrations to highlight different types of biases, and with that we come to the end of this talk. As I promised, I am just going to discuss some pointers which would be useful in the design of such platforms. So very first is that there is a need to understand the socio-cultural impacts of any generative art tool before its deployment. So we need to first question if the algorithm can even solve a given problem, like can the artist style can be even modeled. And there is also a need to define guidelines related to accountability of generative art. So who owns the responsibility for any biases associated with generative art, right? And also there is a need to involve domain experts in the generative art pipeline to better inform the process. And that is where using visual graphs like DAGs can be very handy, because it helps non-domain experts who don't necessarily have an AI knowledge to easily encode their assumptions, which can be incorporated into the model design. And finally, there is a need to outline guidelines for better communication between researchers and developers of such models, much like the data sheets or the model cards, which have been used in different other applications. And that's it. Thank you very much.